we will ask Wendy to begin our presentation.
So I'll provide some background information about our project. The number of deaths on the world road remain unacceptably high, with an estimated about 1.35 million people died every year. That is, one person will die every 25 seconds. Also, the traffic accident is one of the leader killers of children between age 5 to 16, which shows a need of improving road safety. So the Victoria Road Safety Strategy 2021 and 2030 commits to the ambitious target of eliminating deaths from our road by 2050. The first step of the target is halving the number of deaths by 2030. Next, please. So how to deal with this serious problem? The first and most important step is to identify which factor has a significant impact on the severity level. That leads to our goal, evaluating all factors such as vehicle condition, weather condition, and road condition to identify which factor lead to high severity level in the traffic accidents. Then we can control those, So we can control those factors to reduce the crash severity and or even eliminate deaths from our road. Next, please. There are several use cases and personas. For example, police officers can use our systems to set the road speed limit and control traffic flow. The road designers can plan urban road with safe system approach. So human error will not be punished by the death or serious injury. The everyday driver can be trained more efficiently to become a better driver, and also the mobility service provider, such as Uber driver, can use our systems to adjust the fee based on hazard conditions. And of course, data is the driving for the machine learning. So I'll pass to Pi and Christina to provide more information about the data we used in our project.
Hi, in data exploration part, we have 5 small tables, and the first table is restraint helmet use. And in this table, it contains information about the relationship between crash severity and restraint helmet use, and changes among different genders and age groups as the year passes. Intuitively, the relationship between fatality and the percentage helmet use in populations is in positive correlation. Next page, please. And the second table is about the vehicle involvement. And in this table, it contains information about the relationship between crash severity and different types of vehicles, such as motorcycle, truck, and bus in accident as year passes. Intuitively, involving motorcycle causes more fatalities than other type of vehicles. Next page, please. The third table is about alcohol speed fatigue defect. This table contains information about the relationship between crash severity and different types of problems, such as drunk driving, fatigue driving, defective vehicle, and speeding as the years passes. And intuitively, the drunk driving causes the most traffic accidents in all 4 problems. And Christina will talk about the remaining 2 small tables. Thank you.
Thanks, Pi. So in my part, there are 2 tables of the exploration. The first table is the driver involvement. We can see from the line chart that crashes cause fatality remains the lowest and the most stable among the last 20 years. And the data of property damage only are the highest during the first decade, but are not collected after 2010. Crashes involved with hospitalized casualties surpassed medically treated casualties and owns the #1 casualties. All the crashes plummeted after 2020 because of the COVID-19. Next page, please. The next table is the road casualties. we can see from the table, the age group in 17 to 24 generates the most casualties in each police region and each severity. And also this age group has the highest ratio of the fatality. That's all my part. Let me pass to George to introduce the visualization of this data set. Thanks.
Okay, thanks for Christina. And my part is the main table of the data visualization. So which include a relationship between the several conditions with different level severity from 2001 to 2021. And the topic we try to analyze is the traffic accidents in each suburbs and the trend of the total number of traffic accidents happened and which day of the week has the most case and when. And the result we find is the traffic accidents are more likely happen on Friday during 3 to 5 p.m. And faster speed limit, fast speed lead to more dangerous crash severity. And the speed limit of the 60 has the highest case number. Next, please. And this is the dashboard I generate. So the first part is the filter. And the second is the casualty number. I use the scorecard. And the third is the Queensland map. And the fourth is the time. I use the heat map to the month and the days of week. And the time I use the bar chart. And the fifth is the conditions or speed limit is used the pie chart and other conditions is used the bar chart. And the next slide, I'm gonna show the demo how we can use the dashboard. Next, please. And have a look. Okay, so as you can see the map, we can just collect the map, and then you can see the information of the passcode, suburb, and the LGA, and the custody total number. And you also can select, sorry, I don't think the video is. Yeah, and also we can just use the passcode to select which passcode we want to know. And so you can see we also can use the suburb to select which suburb you want to choose. So for example, we go to the Brisbane city. So you can just click, and actually this all dashboard number, all the value they are connected together. And also in the accident over time, you can select speed value you want to know. Like for example, the highest number, you can see it's on the 5-day main, and all information are changed together. And also, you can just select the speak date like Friday, or you want to know the month like December. And also you can just select the year you want to get the information, like if you want to only know the 3 years, so you can just select the select bar. And also in the crash time, you can just select the time like 3 p.m. And most of the crash is happen on the weekdays. And also like when you want to know like 12 a.m., almost the crash on the Saturday and the Sunday. And also in the speed limit, you can just select which speed you want to know, like 50 or the 60 or the 110. And also the conditions, if you want to know only the one condition, you can just select and you can get what's the situation in the Queensland. And also if you want to know combination of the situation, so you can just select and you can see all the information here. And as you can see, the car crash is far from the city. Okay, and this is my part of the dashboard, and I will pass to the Sylvia, sorry.
Thank you, George. So now it's my part for the data visualization of drivers' information. So the background of this part is it includes two tables. The first is the driver's demographics, and the second is alcohol, speed, fatigue, and detect. The analyzed topic include which gender and age group plays a dominant role in all crashes, which license type accounts for the majority of all crashes, and which traffic offense has greater impact on each crash severity type. The interpreted results, so we get from these tables are male drivers aged between 24 and 59 years old plays a dominant role in all crashes, and the full license drivers account for the majority of all crashes in the Queensland region. And the crash related to traffic offense take a small part of all total crashes. And the crashes related to traffic offense has a higher fatality and hospitalization rate. Next page, please. So here's a dashboard I created, just as the one that George presented for the main table. So it includes the first part is a filter, and the second part is driver's demographics, which is a tornado chart. And the third part is the license type and crash severity, which is a bar chart. And the fourth type is a traffic offense on crash severity, which is a donut chart, 6 donut charts. And the last part is percentage of count of causality over crash year, which is a bar chart. Next page, please. Okay, so here's the dashboard demonstrating the driver's information, including their age, gender, and license type, and the traffic offense, such as drink and speed driving in the past 20 years in all crashes police region in Queensland. The first row shows the filters, including the crash year, crash region, and reset filter button. Now I'm gonna choose year up to 2009, and in Brisbane for the demonstration. So if you look at the buffer chart, it's pretty straightforward that the male driver age between 25 to 59 plays a dominant part in all crashes. As for the license type, the bar chart shows the full license type is a primary license type for collisions. If you look at the two tips for each license type, you can see that no matter what the license type is, it all results mostly in hospitalization and followed by medical treatment. So the third area for the driver's information is about the traffic offense. So the 6 donut chart shows the percentage of different types of traffic offense from left to right in descending order. And the color shows the severity of the crashes. So the darker the color is, the severe the crashes are. Normal, aka no offense, accounts for the largest amount for all crashes, where in offense, drunk driving has the largest causalities. We can see that the fatality rate increases if the offense is mixed. That is to say, if the driver is drunk and speed driving at the same time, it's very likely that the crashes are fatal. So I'm gonna reset all filters for the last part. So the last part shows some seasonality of the crashes, which indicates that in 2009 is when the crashes happen most frequently. So here's all my presentation for the driver's information dashboard. Thanks for watching. I will pass to Ivan for the next part. Thank you.
Next one, we'll talk about the machine learning models we have used to analyze the Queensland traffic accidents. We have in this time we have selected the decision tree classifier. It is a simple supervised learning machine learning models, and it develops a set of rules to make classifications. The basic theory of the decision tree classifier is an internal node represent the features, and the branch represents the decision rule, and each leaf node represents the outcome. And it will help the users to understand the major factors cause high severity of traffic accidents. The benefit of using the decision tree classifier is that the first is it requires less effort for data preparation during data preprocessing. And the second is to easy to handle the missing values and faulty values in a data set. That even kind of some errors in the data, you won't have affect the outcome, and even the performance of the decision tree classifier, and which these two major benefits will help the users to easy to understand the outcomes of the decision tree model. And next, I will going to show the demo that represents the decision models of analyzing the traffic accidents. Here's the decision tree model we have developed. As you can see, when the crash speed limit is greater than 65 and less than 80, most cases are classified as hospitalization and even fatal when there is not a multi-vehicle crash. And when the crash speed limit is less than 65 and is not having very quite serious cases that mostly classified on medical treatment and even the minor injuries. However, there's one special cases that when the unit cars crashes, not that much, even which will be classified as fatal, as these traffic accidents will lead to a pedestrian being affected by the traffic accident, that will causing more serious cases that will lead to fatal. Here's the decision tree model we have developed. In the summary of the project, we have provided some suggestions for the government that they can improve the speed limit on special locations to reduce the traffic accidents. The second is they can add more traffic control authorities in certain suburbs to save more lives after being impacted by traffic accidents. And the third one is to improve the road design to avoid multi-vehicle crash. If the Queensland government has successfully to handle all the traffic accidents happens in Queensland, we believe that in the future they will provide safe road conditions for the drivers and a safe environment for pedestrians, and even achieve the final goal, which they will create a safe and beautiful communities for Queensland. Here's the end of the presentation, and thank you very much, and hope you can enjoy it.
Cool. Thanks very much, Team QTF Solutions. Just wondering if anyone has any sort of questions for the team.
Thank you.
Yeah, Chris. So the first question is, what's your average accuracy for your model? And do you have any sort of like future plans to improve the accuracy of your model? So that's the first question. And second one is, do you have any plans or actions to avoid overfitting of your model?
The average accuracy we have been tested for using a decision tree by changing several parameters that we had tried to use the Gini index and the entropy as for testing. The major accuracy can result in when we're going to select the entropy for training the data. We are providing high accuracy that is about 85%, and when using Gini index, it will be around 82%. And overall, it is mainly high because entropy will have more punishment on the effective of the data. So in order to having high accuracy, we decided to use the entropy as the criterion of the decision tree. In order to, if we want to do the further improvement on the decision tree model, we can set the minimum sample leaves and even the max step in order to control the tree, in order to control the nodes being expanded and even being grown. So such as like when we set the minimum sample leaf to 1,000, we will kind to restrict that the characteristic will be split. Only the samples is over 1,000. It will the settings we're trying to avoid. We're trying to avoid some not quite useful characteristic being identified or splitting on the decision tree. That is quite useful when we're trying to train the data. In order to avoid overfittings, we still need to test the max staff. During the time we're trying to testing all the decision tree, I had trying to set the max staff from 1 to 10. And it's quite easy to see that when the max step is equal to 3, around 3 to 4, the overfitting issues is the least overfitting issues. Yeah, but anyway, if we still want to reduce the overfitting issues, we still need to have more tests on the decision tree. And also the decision tree models have one kind of disadvantages that they will very easy to use to have overfitting when implemented what kind of data set have been implemented into the models. At that time that I'm trying to use the random forest classifier and even the SG boost to handle different cases of data sets. this is all the answers for Grace. And now for Siying, and I saw her question is, have you considered any other models than decision tree classifier? Absolutely. The decision tree model is the baseline model we're trying to do the test. And for as I just said before, and I can use if we want to make the more perfect models for identifying the characteristics of which affect the different severity of Queensland traffic accidents, we can use the random forest classifier and even the SG boost. And one of my teammates used to introduce another method, which is the gradient boost regressor. However, this is you are providing high accuracy. However, it is another different approach of the machine learning. Yep, this is all the answers. Thank you.
Oh, thanks very much for your answer, Team QTF. And one thing I can add over here for Siying is, I think in the insurance pricing, car crashes modeling, for example, frequency severity, those are the bread and butter. So we've done that day in, day out, and that's so if you try to get some more sort of like a feedback from Siying, that'll be really awesome to improve the project we've done with the Queensland Traffic.